Okay, this is chapter 5.6, Proving Triangle Congruence by ASA and AAS. You're probably wondering what in the world? Well, it's really quite simple. The essential question here is what information is sufficient to determine whether two triangles are congruent? And what you will learn is how to use the ASA and the AAS congruence theorems. ASA is angle, side, angle, where the side's included between the two angles, and angle, angle, side is two angles and a non-included side. And we'll get into that in this chapter section. Okay, so using the ASA and AAS congruence theorem, so we first have to go over the two theorems before we put them to use. And theorem 5.10 is angle side angle, or ASA congruence theorem. And it says if two angles and the included side, so let's look at this diagram. Angle A is marked as congruent to angle D. Angle C is marked as congruent to angle F. So the two angles that are marked congruent if the side in between them is marked. So the included side means the side that forms those two angles. So if I say segment AC, I'm saying the two vertices, angle A and angle C, make side AC. Angle D and angle F make side DF, okay? So if two angles and the included side of one triangle are congruent to two angles and the included side of a second, then the two triangles are congruent. So A is congruent to D, angle C is congruent to angle F, and side AC is congruent to side DF, then the two triangles are congruent. There is a proof on page 270 you can review on your own. I'm not going to go over the proofs. We're just going to explain it as I do the examples. And then we have the angle side congruence theorem, also known as AAS. So notice where the S is here. It's in between the two angles. So the side is in between the two angles. Here, the side is not in between the two angles. So if we have two angles, it'd either be BC or side AB that are not in between. We can't use AC because we'd be using this theorem up here. So this side is not in between the two congruent angles. So this says if two angles and a non-included side, so angle A is congruent to angle D, which it says right here. Angle C is congruent to angle F. Now we're not using ASA, so we're not talking about AC and DF. It either would be AB's congruent to DE or BC's congruent to EF. The two non-included sides are the only ones we can use in the angle side theorem. So if we have two angles and a side that's not included, congruent, then the triangles are congruent. That proof is on page 271 in the book if you wish to look at that, but I'm going to explain it as we go with the examples. So let's look at them. Okay, so example 1 says identifying congruent triangles. Can the triangles be proven congruent with the information given in the diagram? If so, state the theorem you would use. So in this diagram here, we have a triangle right here, this triangle right here, and then we have, oh, I don't know, how about lime green? And then we have this triangle right here. And the question is, are these two triangles congruent? Okay. Let me see, what could I use? Maybe yellow would work in this diagram. All right, so this angle is marked congruent to this angle. So we have an angle congruent to an angle. Fantastic. We have a side congruent to a side. Now we have an A and an S. So the question is, can I use side or angle side to prove these two triangles are congruent? Okay, well, if you don't forget, these are straight. This is a straight line, and this is a straight line, and they're forming vertical angles, and vertical angles are congruent from way back in a previous chapter. So I now have two angles and a non-included side. You have to be able to identify what sides are included. So if I have two angles marked, this side here, this one here would be included. All right. So it's not angle side angle. It's not actually not SAS. We also have angle side angle. We aren't doing side angle side this chapter. Angle side angle. Is the side included or is it not included? Well, we have two angles, so we have two A's. We have two angles and a non-included side. So that would be angle, angle, side. So then if I get rid of this box here, that'd be the explanation. The vertical angles are congruent. So two pairs of angles and a pair of non-included sides are congruent. The triangles are congruent by angle, angle, side congruence theorem. Okay. All right, now we're looking at this umbrella. And we have this angle congruent to this angle. So this is congruent to that. We have two marks here. So it's congruent to this triangle. And then finally, we have three marks here and three marks here. All right. So are these two angles or triangles congruent? We have three angles congruent to three angles. So if this was 40 degrees, this is 40. If this was 50, this would be 50, and therefore these would be 90, but obviously they're not. By the triangle sum theorem, all triangles add up to 180, but the side lengths are not being taken into account here. And we need side lengths to limit how big or small the triangles are. These two triangles are similar, but we can't prove they're congruent. So we'd say there's not enough information to prove the triangles are congruent because no sides are known to be congruent. So we need at least one side to keep the triangles at a certain size. All right. Okay, so let's take a look at C. C is a set of stairs with a railing, and we have two triangles. So again, let me identify the triangles using colors. Again, we'll do red. So if I start here and go up to here, and then here's the rail, and then back down to here. And the other one, whoops, the other one, I will make blue. So again, that's too thick. Then we have this triangle here. These are the two triangles we were given. Okay, so now if I mark these, this had one mark and this had one mark. So that is one angle congruent to an angle. This one has two, this one has two. Now we have two angles congruent to two angles. So I have an angle, I have an angle, I have an angle, I have an angle. Do I have an included side or a non-included side? So when I look at this, they're sharing that diagonal. So the reflexive property is going to say that that side is congruent to itself in both triangles, and that is in between the two angles that are marked. So it's angle, side, angle. So to identify that, we would simply just state two pairs of angles and their included side are congruent. Therefore, the triangles are congruent by ASA congruence theorem. Okay, so hopefully these three examples help. This is angle, angle, side, not enough information, and angle, side, angle. So now you should be able to do problem numbers 3, 4, 7, 8, 9, and 10 on your homework. Okay, example 2, using angle, side, angle congruence theorem, write a proof. Everybody's favorite. Okay, so these proofs are really simple though. So it says given segment AD is parallel to segment EC. Always look in the diagram. Sometimes they mark it, sometimes they don't. There's my parallel marker. AD is parallel to CE. Okay, whenever we have two parallel lines and then we have lines going across like this, those are transversals, and that's why we did those in the previous chapters. So we have two transversals. AE is a transversal, DC is a transversal to AD and CE, which are parallel. BD is congruent to BC, all right? Just making sure everything is labeled up in the diagram. And we start our proof. We're trying to prove these two triangles are congruent. Prove triangle ABD is congruent to triangle EBC. So the first thing I'm going to do is state my givens. So they told us AD is parallel to EC, and therefore that's given. Okay, really simple. We have to state the obvious and then work towards the less obvious until it becomes all obvious. All right, our step 2, our other given. Actually, no, that's not a given. Angle D is congruent to angle C. Okay, so this is what they're labeling. Angle D is congruent to angle C? Well, if these are parallel lines and DC is a transversal, and let me draw that so you can see it more clearly. Let me make it purple. If I drew this right here, hopefully now you can see that that is a transversal cutting through these two parallel lines. Okay, so when we have transversals, we have what are called alternate interior angles. These angles are in between the two parallel lines. And if I can make it even clearer if I draw, okay, I'll turn that green, whatever. I wanted to draw another segment. And let's make this one purple and thinner. So here's what we have. These two lines are parallel, cut by a transversal. So now can you see these two angles are alternate interiors? All right, so that's what we're talking about here. Angle D is congruent to angle C because alternate interior angles are congruent. Okay, so now we want to state, we could have stated the other given first, but we threw that in there. So now I'm going to say BD is congruent to BC, and that is a given. Now notice what we have here. Angle D congruent to angle C, we have an angle congruent to an angle. Side BD is congruent to side BC, or segment BD is congruent to segment BC. It was given, and that's a side. So we have an angle, we have a side. Now do we have an included angle or an included side or a non-included side? What's next? So now I see this right here. This angle here and this angle here are classic vertical angles. When you have two parallel lines and two transversals that cross, you get vertical angles. Okay, so now I'm going to state that. Angle ABD is congruent to angle EBC. Be careful naming these because angle A and angle E are going to go together. B has to be together, so B is in the middle. And D we know is congruent to C, so the D and the C have to line up. In other words, I cannot say angle ABD is congruent to angle CEB or CBE. I can't go CBE, it's the wrong order. D is congruent to C. They both have to be in the same position in the naming of the angles. And now I have another angle. And the reason is vertical angles are congruent. Okay. So now look what we have. We have an angle, we have a side, we have an angle. So is it angle, angle, side, or is it angle, side, angle? That is the question. Okay, so I look at this. The side is in between the two angles. The side is in between the two angles. So now I can say what we were trying to prove. We can say triangle ABD is congruent to triangle EBC. And this is by ASA. Okay, because the side is in between the two angles that are congruent. Okay, so now I want you to try problem number 17. It's in blue because it's an option, it's optional. But the more effort you put into this course, the more you get out of it. So if you try what I suggest, but don't make mandatory, you're going to strengthen your skills. So try doing a proof on number 17. Okay, example 3, using angle side congruence theorem. Hint, hint. This is going to be the reason for our proof. Okay, so it says to write a proof given. Again, we always check to see if everything is labeled. So HF, segment HF is parallel to GK. HF parallel to GK. It's labeled. So these two sides are parallel. GH is now a transversal. Okay, just like the last example. And we're given angle F and angle K are right angles. That's also been labeled in the diagram. So those are our givens. And we're trying to prove these two triangles that are sharing this side, hint, hint, reflexive property, are congruent. All right, so here we go. First things first, let's state the givens. HF is parallel to GK. Reason, given. Pretty simple, all right? Now I could say angle F and angle K are right angles, but let's just do the next step first. We could also do this as well. Angle GHF, angle GHF is right here. And always label your diagram as you list it. is congruent to angle HGK. Okay, why? Well, we have two parallel lines cut by a transversal. These are alternate interior angles. Okay, so that's an angle. We have an angle. All right. Hello. Our other given is an angle. Yippee skippy. Hit enter. Angle F is congruent to angle K because they're both right angles. That's a given. Okay. F is congruent to K, or I shouldn't say congruent yet. Angle F and angle K are right angles. That is given, but now we can say they are congruent because right angles congruence theorem. If two angles are right angles, they're both 90 degrees. Obviously, they're congruent. So now we have an angle and an angle. So now the big question is, do we have AAS or do we have ASA? And obviously, it's going to be AAS. Now we can say GH is congruent to itself. Agree? Okay. HG is congruent to GH. Now keep in mind, this is a rotation. So GH in one triangle is HG in the other because it has to be rotated and we have to go in the same order. And so HG is congruent to GH. And I'm going to explain the naming here. You can't say HG is congruent to HG because you have to be careful with your angles. So HG in one triangle is the first and the third letter, and the first and the third letter in the other triangle is GH. So H is congruent to G, G is congruent to H, HG is congruent to GH. Okay, remember the ordering. It's very important. Okay, so now we can say those two are congruent because reflexive property. So now look what we have. We have an angle, we have an angle, we have a side. We can now say the triangles are congruent. We have two angles in one side, but which is it? Well, the side is not included in between the two angles, so that is AAS. Okay, and so hopefully you're getting a hang of these proofs, and so I would like you to try number 19. Okay, that brings us to the end of exercise 5.6. So the problems I want you to do for your homework are listed here, other than those other two proofs that I would also really like you to try. And then 34 through 36 are review questions. Okay, so thanks for watching and have a great day.